So today we start describing the properties of receptor. Now the first property that we will describe is adequate stimulus. The most appropriate stimulus to which a receptor is most sensitive is its adequate stimulus. The most appropriate stimulus to which a receptor is most sensitive is its adequate stimulus. For example, both light and pressure can stimulate a photoreceptor. Both light and pressure can stimulate a photoreceptor. However, the photoreceptor responds to light with much higher degree of sensitivity at a much lower threshold. The photoreceptor responds to light to a much higher degree of sensitivity at a much lower threshold. So, light is the adequate stimulus of photoreceptors. Now, next we come to doctrine of specific nerve energies. Doctrine of specific nerve energies. Now, the nerve pathway from a receptor, nerve pathway from a receptor to the site of termination at the cerebral cortex is distinct. Any stimulus exciting this pathway anywhere in its course will produce the specific sensation evoked by the receptor. Any stimulus exciting this pathway anywhere in its course will produce the specific sensation evoked by the receptor. This is also called the label line principle. This is also called the label line principle. So, it comes that from the receptor, the pathway going right over to the cortex is distinct for a particular sensation. So, anywhere when the pathway is stimulated anywhere along its course, the sensation felt will be the sensation for which it is meant, that is, it will be a touch or a temperature, whatever it may be. The sensation evoked will be the sensation for which this pathway is meant, and that is called doctrine of specific nerve energies. Of course, this contradicts the overstimulation hypothesis, according to which the when a pathway is stimulated to a much greater degree, it will produce pain. That is, pain is produced by overstimulation of any type of receptor pathway. But this overstimulation hypothesis has been discarded now. Now, also here we can describe the law of projection. When the nerve path from the receptor to the cerebral cortex is stimulated anywhere along the course, the sensation caused by the stimulus always appears to originate from the exact location of the receptor. This is the law of projection. So, when the nerve path from the receptor to the cerebral cortex is stimulated anywhere along the course, the sensation caused by the stimulus always appears to originate from the exact location of the receptor. This is the law of projection. So, here you can see the pathway of a particular type of sensation. This pathway, when this pathway is stimulated anywhere along the course, then the sensation felt will always appear to originate from the site of the receptor, This is called the law of projection. And from this, the phantom limb phenomena can be explained, but that will be for later. Now, next we come to Waiver-Fechner law. Now what is this? Now when intensity of stimulus is increased 10 times, sensation felt only doubles. When intensity of stimulus is increased 10 times, sensation felt only doubles. The sensation felt appears to vary with log of intensity of stimulus. This is Waiver law. So when intensity of stimulus is increased 10 times, sensation felt only doubles. The sensation felt appears to vary with the log of intensity of stimulus. This is what is known as Weber-Fechner's law. However, now it is shown that more accurately sensation felt varies with a power function of the intensity of stimulus. Now it is shown that more accurately sensation felt varies with the power function of intensity of stimulus, and that is called power law. Mathematically, it is R is equal to k into s minus k whole to the power of y. So R is equal to k into s minus small k whole to the power of y, where R is the sensation felt, s is the intensity of stimulus, and large k, small k, and y are constants. So that is Waiver-Fechner law. Now next we come to lateral inhibition. Lateral inhibition. Now in this slide, we can see an object, and an object stimulates three receptors. Object stimulates three receptors. The central receptor, in more intimate contact with the object, is stimulated much more strongly. You can see the frequency of action potentials shown here transversely is much greater in this central neuron than in the lateral neuron. Here you can see the transverse lines are much rarer or much less. Now, so action potentials of higher frequency will be transmitted by the central neuron, while the lateral neurons will carry action potentials of lower frequency. Now each neuron inhibits the neurons lateral to it according to the principle of lateral inhibition. Each neuron inhibits the neurons lateral to it according to the principle of lateral inhibition. Now since the transmitted impulse is stronger in the central neuron, it inhibits the lateral neurons strongly by inhibitory interneurons. The lateral neurons also try to inhibit. The lateral neurons also try to inhibit the central neuron, but as the impulses transmitted in the lateral neurons are weak, the inhibitory effects on the central neurons are also weak. The net effect is that the central neuron transmits a much stronger signal than the lateral neurons. Thus, the original degree of stimulation of the three receptors, is accurately reflected by the neurons due to lateral inhibition. This helps in accurate localization. Of the object. So let us describe the things again. uh, the central receptor.